survey for courses? Would it be useful because you'd like to improve explanations in the MOOC you're teaching now? You know, I'd be really curious to get people's practical thoughts on that, where this could be applied. I think everything's set up there. Cool. Okay, so basically, if you want to, I'll put the link up to talk afterwards if you want to see it or share or see slides. And this is just information about the more general formalism I've used to support this. This is something called MOOClets, which I think you've heard me talk about before, but it's sort of made huge strides since then, especially with feedback from course teams. And there's like an overview, like more general talk, kind of explain this idea. Okay, so to give you a sense of what I'll cover, I think the key goal I have here is how can we help instructors to provide good explanations to students? How to solve math problems of concepts that maybe weren't completely covered in a video. And how can we build tools that let them do this semi-automatically by automatically collecting data and then putting it into practice. But do this in a way that makes it easy for instructors, in that it's automated, but also actually allows them to step in at any point and maintain control over what's happening. And so I'm going to present one example of a system. We call it ACCESS for Adaptive Explanation Improvement System. And basically, this is a plugin that I built to adapt explanations for how to solve math problems. So if you've got a problem and you eventually get the answer, it will then give you an explanation of why that answer was correct. And the idea is this is a plugin that you can stick into edX. If you take your normal problems in edX, you can sort of add this on top of it, and also into Canvas. So it's designed to be cross-platform. It could also be useful for on-campus courses or even just sending emails out because it can be standalone. So an instructor could just say, well, here's something I think students should explain. You know, why did World War II occur? And they send this link out, and students will type the explanations in, and then they'll actually get other people's explanations. So it helps sort of collect explanations and provide good ones. So I'm going to talk about the student view. What does a student see on the front end? Then the back end, and I'm going to go over that very lightly, but this is sort of using machine learning so that we can do experiments to see which explanations are good. But do them ethically in the sense that we don't just figure out what's working. As soon as we figure out what's working, we're putting that into practice so that if an explanation is rated highly, more and more students are getting it. So as we're learning what's working, we're actually deploying that. And then finally, the instructor view. And I'm just going to show a very kind of rough prototype. A lot of these systems are meant to just show you what an instructor could do. But you know, I would work with more serious software engineers to make this something more programmatic if it was interesting. I'll talk about how I deployed it as a pilot, and then how we evaluated whether it helped learning. But I think the real question, again, is how would you use something like ACCESS or any system like this? And I'd be really curious for your thoughts. So as you hear me talking, if you don't mind thinking, well, where would this be useful? What's wrong with it? What are its limitations? What else would you like to see? Because there are many contexts where we are going to want to provide explanations. I mean, explanations are building blocks of courses in some way. I'm not going to talk about this here, but I've actually started working on how we can personalize explanations to different people. And then some other kind of interesting ideas. Everything I say here about explanations can carry over to other kinds of text. Because if you can give people different versions of an explanation for how to solve a math problem, you could give them different versions of a motivational message. Or you could send them different emails. And these tools basically allow any instructor, any course team to say, instead of just sending one email, I'm going to specify like different subject lines. I'm just going to type these out, and I'm going to send them out to students. And as I get feedback about which subject lines are making people open emails or making them motivated, this system is going to automatically give those to more future students. And so it's meant to be a sort of a system that makes it easy to try out more experimentation automatically. Okay. So in terms of providing explanations to students, this is, you might imagine, in any MOOC we've got to do this. So for example, in ChinaX, there's lectures, there's problems. You can imagine, well, do we want to add explanations for why answers are correct? And that's something you can currently do in edX, but you tend to really provide one. Or some problems, actually, we just don't have time to go in and write explanations. Or you might also think, well, suppose students don't understand concepts about a video. You might have a discussion forum where someone asks a question, and an answer can come from another student. But is there a more principled way to plug in this tool so that we can actually evaluate whether those answers are good and automatically provide good ones to more students? You can also imagine this problem coming up in on-campus courses. So this is an extension school course where there are quizzes that ask people questions, but often after someone answers it, they just get the answer. The instructor may not have had time to write explanations, or they may have written one, but they're just not sure if it's helping students or not. So these are both kind of settings that are the targets of the kind of system I'm building. How do we add explanations into these courses and continually improve them as we see which ones are actually helping students? So to zoom in a bit more, here's an example of a question in Chinex. It's a multiple choice one. And you might think, well, after you check, you could give someone an explanation of why that answer is right. And this Chinex is actually pretty good about doing this in most questions. But a lot of MOOCs actually, you may not have time to write it for every question. Or you may write something, but then 2 weeks, a year later, you might have a new idea. Should you just stick your new idea? Could you compare your new idea to an old one? And also students themselves often have some really good ideas about how to explain concepts to other people. So it'd be nice if there was a way to harvest their explanations and then actually deploy them to other students. Similarly in Canvas, here's an example of the question, where you ask a question, people get answers, and again, we'd like to be able to provide explanations of why an answer is correct. So students aren't just clicking and getting answers, but they're understanding it.
What is that? Is that a real setting, or is that from a real course?
Yes, exactly. Both of these were settings from courses.
And what is this? Which course?
This is from a Canvas calculus course that the extension school is running.
The Harvard Extension School, right?
Exactly.
And those are students drawn, or
no, this is just by the instructor. So to me, these are just trying to give you some context for the kinds of situations we can apply this to. And these are projects I'm trying to sort of start now, which is with Canvas. I had a meeting with the extension school meeting to say, well, let's add in this system so that students actually do get explanations after they get an answer correct or not. And with Chinex, I have been looking and seeing if is there a suitable place where they could also add in the system.
But those are just both questions, right? Yeah.
Exactly, yeah. So I'm treating it just for the talk. I'm just going to start scoped on questions, but I think all of you can come up with other interesting applications. Okay, so here's the front end and basically how we deployed this. So, this is just again more concrete examples, but this is what actually normally happens in a MOOC. You get an explanation. Sometimes this doesn't exist, and sometimes it does, but you might improve it. So here's the basic approach of the system. Where you see this explanation, you'd actually imagine you plug in this tool I'm talking about, this access tool, where instead of using this native feature, you'd actually just plug it in. So it looks to the student just like it's part of edX, but it's going to add some extra functionality. So here's how it might work. Before they see that explanation, and they've just got the correct answer, you can imagine asking students, well, why is that answer right? So you'd ask them this because there's actually a great deal of research, and this is something I did my dissertation on in psychology, that just asking someone to explain why an answer is correct can actually help them learn. Sometimes it even helps them learn more than telling them why the answer is correct, because they actually construct the knowledge and find the underlying principle.
If they get the wrong answer and explain to themselves why it is correct, is it actually also good, or is it actually worse than not explaining at all?
There's some papers that argue it either way. It depends on the context. In this kind of context, it's probably actually a bit helpful for them because they articulate their misconception. And then the misconception often conflicts a bit with the answer, or at least it conflicts with the correct explanation. So sometimes even if people explain things the wrong way, as long as there's enough support that they can see why it was wrong, then it actually can be better. Whereas if they hadn't explained it, they just have read this and be like, I think I get it, I'm gone on.
So the way you implement it, tell them whether you didn't tell them whether it was right or wrong before you.
No, actually, I do, because they enter the answer, they check, and then they see the right, when they get the right answer, that's when I prompt them, okay, why is that answer correct?
If they got it wrong, so.
Exactly, but I would wait until they would get it wrong, but then they would be told it's wrong, and then they'd eventually get it right. So I would wait until they see the right answer. So this always happens when they know what the correct answer is. The system told them, okay, this is the right answer. So you might say, well, why is that answer right? And there's a text box so you can jot the ideas in. Or you can imagine many ways to ask this question. Could you explain to another learner why that answer is right? And all of these questions are designed to get students to reflect so they're going to learn. But they actually have a second goal, right? Because this helps an individual student learn that moment, but it might also actually provide an explanation that we can provide to another student. So the future student, the next 5 students, the student a day later, could actually get that explanation, and seeing someone else's explanation might actually work for them. This would be especially important when these explanations just don't exist at all. And it's true, if you flick through many of the MOOCs, there are places where there's just no explanation. You don't have time to write them. Even when there are explanations, you could imagine that this one may not be the best explanation for everyone. You could actually imagine another student writing one that maybe is a bit simpler, one that sort of hits on the key ideas so they get students where their knowledge is at.
Just I might bring an example.
Oh, yeah.
The way that I would, this is not scientifically rigorous, but I would say that the benefit of this is inversely proportional to the complexity of a problem.
Okay.
Right, so like for a multiple choice or something that's kind of straightforward, this should work really well. Like pausing and saying, why is this answer right? More simple case. But in physics education research, it's fascinating because you might have a problem that takes an hour for a student to do. Multi-part, multiple concepts here, and just asking why was that right could reinforce a misconception.
Yes.
Right? Especially with the caveat that you're not telling them what they got right before.
Yes.
But so one reason I brought that up, a key point for me, you just touched on it, is that rather than explain this, as a physics education researcher with a complex problem, you could say, I know that there are like these 2 or 3 pain points. There are misconceptions. What I could do is ask them to explain one of those pain points before moving on to see an explanation or something. So
that's a good idea. Yeah, it can be a good direction.
So it's no longer like an explanation as so much as it's like I'm going to ask you to explain a very specific key point in this big problem.
Yeah,
that makes sense.
Maybe jumping ahead, but is there something in the way the question is staged that makes them do this? Can they skip past this?
They can skip past it. So I mean, in general,
how many people actually do this?
So let me think. I haven't deployed this in a MOOC setting, so that's something I think would be good to know to do. So I don't actually know how many people would do it. I would suspect that, even if a tiny minority of people do it, that's probably still okay. When I ran this pilot with just participants who I recruited to engage in a study, a lot of them just didn't even bother to fill it out.
You didn't have to.
No, they didn't have to. But the thing that's actually kind of nice about that is that then the people who do fill it out tend to give better explanations. One thing I think would be really nice to play around with, especially in a MOOC setting, would be thinking, can we get people to get some of the benefits of reflecting, even if they don't write that text out? And so there are 2 ways I've started to explore this. One is with a grad student in computer science, where he's actually built a bit of JavaScript that you could plug into edX that will ask people to talk out loud. So could you explain to the learner why it's right? And they click a button, and they say it, and then they move on. The reason that's really nice is that then it's a lot more natural for a learner. They can actually just sort of say out loud, they're like, well, I think it's right because in China they did, oh no, I'm wrong. And then they basically got the insights. Another approach could actually be, and this is something I think would be very easy to test, rate on a scale from 1 to 7, how well could you explain to someone else why the answer is right? And so the idea is that in making that numerical judgment, it would actually make you do, a tiny bit, 20% of what you would do if you actually wrote it out. So I think, well, how well could I explain to someone else why this is the right answer? Well, I could say to them that it's because China was invaded in this year, and I think it's because of that. Okay, like a 4. So the idea would be it's a way of eliciting some of the same cognitive activity, even without having the word process. But that's an empirical question. I think it'd be easy to test, and I'd love to.
Well, that was very interesting. So where are you going with that practically? Is that an alternative teaching strategy? You might replace the whole explanation with that?
Exactly. So that's a bit of a tangent, but I think it's sort of an instructional design strategy, where like if you don't care as much about getting explanations to give to other students, but you just care about helping these students who would never even explain at all, then I think having that kind of light touch judgment could be good. So that's kind of a separate line of work. Okay, so here's, in terms of looking at the actual system, The idea, as I mentioned, is to plug in. And the student view is going to prompt learners to explain. It's going to then provide them with other people's explanations. I'll talk a bit about the back end and how we figure out which explanations to provide. And then also I'm going to talk about the instructor view. And the key thing here is that the instructor should not have to do anything. The system should they should say, Joseph, plug this in, and I plug it in. And then it should run on its own. But they should have the option to. So they should be able to see what explanations are actually going out and how likely these explanations are presented. Some explanations might just go to 10% of people if we're not sure if they're very good. Others might be going to 70%. They should also actually be getting data back in real time. So every time a student rates an explanation and say, this one was really useful, that data should be visible to instructor. And they should have the option to say, well, I think this is not a good explanation, so I'm going to give it a really low rating, and I don't want to see it go to many of my students. Or they might actually say, well, I like this explanation because it made it simple, but I think there's a better one. So they can actually just type into a box, here's a better explanation, and then in real time, that starts going out to students. Okay, so in terms of the actual deployment, this was 150 people I recruited online to just take part in the study. So the idea here is we get a lot of control. We can really test out what's going on. And then I think now that we have this evidence, it'd be nice to deploy it in a MOOC or in Canvas with extensions code. So here's what these learners saw. They would see a math problem like this. So Mary's music store had 5 truckloads of seeds delivered, and so on and so on. And their job is, well, write an expression for how many seeds were delivered. So let's say that they typed it in, they got it right, they got it wrong, and they finally have the answer. Now at this stage, they've got the answer, but often students don't really totally understand why it was correct, or maybe they half get it. This is the point now where we could give people explanations that are written by other students. So for example, that would pop up. Take from step by step, and so on and so on. That explanation is coming from a pool that the student doesn't see, that has come from previous students, or even from instructors or course teams. But basically, explanations being selected from that pool and presented to each student. Then we ask the student, well, how helpful was this explanation for your learning? And so this seems like a very natural part of it, where it's like we're giving them a chance to give feedback, so it's really embedded inside the task. But actually, it also gives us useful data. So they give a rating from 1 to 7. Then we can actually prompt them, well, explain in your own words why that answer is right, or how you got the step. And so then this is the full loop here. You can give people explanations, get a rating, so you know what's working, what's not. But then you give them the chance to really try and, well, explain why, explain in your own words what this is saying. And that's going to help them actually learn from it, rewording what's been said. But it also then provides another explanation that can go into that pool for a future student. Now, one question I'm sure you all have is, okay, so we have a pool of explanations, but which of these are actually going to be good? Which should we be presenting to students? One of the best ways to figure it out is to run an experiment where we randomly assign people to get explanations. 1, 2, 3. We look at their ratings and we figure out which one's actually helping. The one thing is that often when we do experiments, our goal is just to figure out what's working, and we assign people equally to different conditions. So if we have 3 explanations, 33% people get each of those. But that's helping us detect statistically what's happening, but it's not actually necessarily helping those students themselves. So it's not helping students in the course. So the kind of key idea here is let's think about a more ethical kind of experiment, where as soon as we start discovering, well, explanation 1, it looks like people are rating it 6 out of 10. Explanation 2 might be a 7. Well, we're not totally sure. We don't want to give everyone explanation 2 because we might be wrong. We just may not have enough data. But we'd like to start giving more people explanation 2. So the thing that I think makes this experiment ethical is as soon as we start collecting data about what's working, we present that to more people. So for example, if explanation 2 is being rated 7 out of 10, explanation 1 is being rated 6 out of 10, maybe 65% people get explanation 2 and 35% people get explanation 1. And so the key idea here is we're trading off, we're keeping our experiment going because there's random assignment, you never know who's going to get it. So we can actually draw statistical causal conclusions like this explanation is better than that. But we're also at the same time trying to balance that with ethically like helping students. So on average, more people are getting the explanation we think is better. And so how should we actually do this? How do we balance this? So the approach here is to frame the problem computationally. And there's a large literature in machine learning and web analytics, like what Google does, on how do we trade off exploring and discovering what works with actually exploiting, helping actually people reap benefits of that. And so I'm not going to get into these details. I'm trying to make this more as a sort of practical instructor-focused talk. But the kind of key idea is to use what's called multi-embedded algorithms. And I can provide more references on that. But the question is, how do we dynamically use rates to decide which explanations to present to the new students? So every time someone gives us a rating, we want to incorporate that and update our plan for future students. So here's an illustration of some data we might have. So there's exclamation 1, 2, and 3. So let's say so far we've gotten 4 students who rated exclamation 1, 6, 8, 7, average of 6.75. 2 have rated exclamation 2, 3, and 2. And then 3 have rated that one really highly. Now you might think, let's just give everyone that third one, right? And just stop. Could you see why that would be a problem? It looks like that's working, but that could just be statistical noise. Even if 5 people rated as 9, you don't actually know for sure that that's better. It could be if you ran 50, this one turns out to be really good. It's just that those 2 people have a bad rating. So what we really want is some kind of model that's representing this information and kind of constantly updating it. But what we will do is we are going to say, well, so far we have some evidence that exclamation 3 is better. We don't have enough evidence to say, stop everything, give it to everyone. But we have some evidence. So let's actually assign people, let's let the frequency with which people receive explanations be proportional to the evidence we have that that's the best explanation. So what we're doing here is we haven't stopped the experiment, because that would be 100% 0, 0. But we have adapted it so that 55% of people get the higher ranked explanation. Let's say 15 get the low one, and 30. This means that we can keep collecting data. So as we collect the data from 20 more students, every time a rating comes in, these properties are going to shift slightly. And it means that we're sort of converging towards giving the best thing to everyone. But we're not jumping the gun and just stopping the experiment. And the key thing of a system like Axis is that it makes it really easy to do this kind of thing. Like, how would you do this right now in edX's A/B testing tool? Or even in Google's? There are a lot of limitations in what you can do, but Axis is designed to really make this process very easy to adjust like step by step, and also to do it automatically, so that you don't have to go in and change these numbers and make decisions. It does this automatically for you.
So Joseph,
oh yeah.
Google presumably does it automatically.
Google does it with multi-banders and do it automatically, but they often have very strict limitations on what you can and can't do. So, for example, the way Google runs it right now is they'll run a similar algorithm to this, but as soon as like you hit 5%, it's done, and you have to give as soon as there's like a 95% chance this is the best one, they just stop the experiment and give that explanation to everyone. And I mean, there are a lot of similarities in what this does and what Google does, but there's some adaptations here for instructors. For example, Google doesn't let you specify, well, I think this condition is better than another one. So I just want to input that data. So you should keep my opinion in mind while you're running your algorithm.
So I guess I have 3 questions now. What are you talking about, Google? Just search?
Google Analytics lets you run experiments on your website. I mean, maybe we shouldn't go down that path because it's a whole interesting question of like how this is similar to different from.
Maybe at the end we can talk about implementation.
Exactly,
like,
yeah.
Okay.
I think maybe, yeah.
That's fine. I would love to have that conversation.
Exactly.
I could tell if you were talking about an actual system or Google in general. Search.
Actually, in general. I mean, Google Analytics, which lets you test your websites.
Sure. Okay.
So what I should say is, this is kind of adapting some of what's used in industry for an educational context. Let me just say that.
Okay. So the questions I have, one is, how long does it take you to where you have means that you're comfortable with, right? So like if I'm an instructor, let's say I'm doing this in Canvas, where I have 30 students.
Yes.
How many explanations do I have to take before I can actually, give a good one? That makes sense.
I'm going to tell you 2 things. It takes you 0 time, and it takes you forever. What do I mean by that? You deploy the system, and the instructor, you're like, I'm done. That's just running. So in a way, it's 0 time, because you don't have to look at it again. So once it's deployed, the system starts adjusting these probabilities step by step, and you don't have to look at it if you don't want to. So in that sense, it takes 0 time because you've launched it, and you're done. It's going to take care of those things.
Well, like any good teacher,
You want to check
like
it.
That ever happens, right?
So that's when you can go and actually look and see the data. You can change it.
But I don't think
the reason I also want to say it takes forever, though, is because you should never actually stop running this experiment. This will eventually reach 99%, but there's no reason to go in. There's no reason to change anything. You can actually just let it run on its own. So that question of like how long it takes, one is the instructor does not have to answer it. They can leave it up to the system. If they do want to answer it, at any point they can just look and see how it's going and see if they agree or not, and they can tweak it.
So I disagree. I mean, because to some extent you're giving an explanation to somebody.
Yes.
Right. So if your first 8 are bad, right? Like you have 20 students and your first 8 to 10 are bad, or all have the same misconception, that's not a good thing.
Yes.
Right? So, and I think even in the case with a MOOC, it's actually okay maybe because a lot of people that are energetic about MOOCs start early and they're good.
Yes.
Right? You look at the forums, these things get filled up with the answers really, really fast. It's not a bad thing. So it should be okay there, but there's something missing for me, which is like this equilibration time, to where you're in a place where you're comfortable ethically, like with how you're presenting things to students. And you're not like misinforming them.
Yeah, so I think the question you're asking is more, I interpret your first question as it being like, for an instructor to use the system, what's required? I think your question is actually, for the best way to use this in a particular scenario, how does one do that?
It is, but it's also more mechanical, right? Like it's the idea of like, this process takes a certain, like anytime you do explanation work, there's an equilibration, right? Or you write the first one, and then it gets updated as good or bad later.
Yes. I think maybe what I would say is I think it will make a bit more sense later on, like how that might approach, but I'm not sure that I necessarily am trying to answer that question. I think what I'm trying to present here is just a system that lets instructors answer those questions. So for example, yeah, I mean, I think I can sort of give you the principles I've learned from specific scenarios, like for math problems, like this deployment, here's how long it took, and here's what I was concerned about. So I'm happy to get into that. I think maybe, I suspect that depends a lot on the dynamics of the particular scenario in. And I think that the point here is not to say we've solved that problem. The point here is to say, here's a tool that makes it easier for instructors to solve that problem.
No,
yeah. But I think it's a great question. Maybe we can come back to it. And I'm generally curious to answer that kind of question in realistic settings.
The last thing I'll say is I think it's super important here to talk about it in terms, like for instructors,
yes,
to talk about what this like equilibration phase is, right?
Sure.
To where your students are actually getting like an optimal type of explanation. At the same time, I'm super curious, and we can move on, but I'm super curious about like I don't know if I use this, but inter-rater reliability or something.
Yes.
In a MOOC, if I get something from a teacher, right, and I know that, like this is somebody who's been teaching calculus for 10 years, we have that in the demographic background, I might interpret their rating a little differently.
Exactly.
So there's a whole other question to me around like kinds of means that you have. This is like a example you're giving, but that's another part of equilibration, right? You might have really differing opinions on the quality of that. Right?
No, I think these are great questions. I feel like I've already succeeded because you're asking these questions.
Yeah, sure.
Because I'm just saying, I was presented to say, here's something that lets us start exploring these questions. And I think those are absolutely right questions to be asking. And I'm glad that this kind of system would let instructors ask it. For example, they can say, well, should I be rating every student's rating equally, or should I tell the system to rate students who have high prior knowledge higher? They can also say, well, when I deploy the system, how long should I check it every week or every 5 weeks? I think that's a great point. I think the point I would make is right now, you can't ask those questions.
Okay.
Like right now, you deploy one explanation, and it's there forever until a year later. You're like, I'm going to go and change that. Okay. So I think it's basically trying to answer exactly, like allow people to even ask those questions.
Okay. I was going to ask a more general question. It seems that, at least for the methodology or thinking behind your experiment, a lot of the same thought has gone into peer-to-peer assessment.
Yep.
And peer review essay, although it doesn't always have to be an essay. You can do a very short question, and it seems like a lot of the same functionality is there. And I'm just wondering if you've thought about the differences between the different peer-to-peer approaches and this approach, and
no, that's a great question. How does this relate to that? I have thought about it, and I'd be happy to discuss it more. I think that the peer-to-peer kind of work tries to say, well, how do we collect good feedback, good ratings from people and share them with others? I think that what I'm presenting here is a system that will make it easier to answer that question by providing experiments that actually compare one pair's feedback to another. Like, for example, there's a paper by Chris Peach about tuned models of pair assessment in MOOCs. They basically answer the question of, how should we rate different pairs' explanations by trying to look for features that were correlated with good judgments and how much of pairs align with instructors. This is actually saying, well, here's another approach. You could actually just present many people's explanations and then just actually empirically see which ones are rated highly or lower.
It would be nice if more of the algorithm behind selecting best essays would be used in the peer assignments, because the problem that I face is that often it's the first top-rated peer essays that are then shown as good explanations for other students. And sometimes those are really terrible explanations. They've just been graded highly.
Yep, that's exactly right.
If those could be then graded more poorly down the line, or more randomness as far as which explanations people have seen.
Exactly. Instead of saying, look, it's 9, bam, 100%, let's keep it around, because as data comes in, we can actually scale back. No, that's exactly right. And I think also we could apply some of those models. Like, I made an assumption here, which is everyone's rating is the same. If Daniel said 9 and I said 8, we're the same. But if you know Daniel's a good student, then actually Daniel should get, like, when he says 9, it should be like 3 9s. When I say 8, it should be like half an 8. And I think I can get into this more, but I'm basically using a Bayesian algorithm that actually is very well suited for that kind of approach. I'm not going to get into this talk, but okay. So basically, here's how it actually works, I think, getting at some of these issues. What we actually do is we basically, you can think of empirical ratings as being what students actually say. But if you think about it, before we even get to that point, when I add a new explanation in, how often should I show it, right? So what we actually do, and this is where the Bayesian component comes in, we're trying to say, well, we want to figure out a probability that you should present explanations, which is proportional to how likely you think they are, what you think their true good rating is. So there are two ways to get that true rating. One is empirically, like actually how many students rated. But another is actually what you can think of as like prior or expert judgment. So before you even see any data, if you look at explanation 1, 2, or 3, do you think it's going to be good or not? Now, I'm going to be honest, in our system implementation, we decided we're going to assume all explanations are equally good. We're not going to use any judgment. We just put them in. But this actually, we still implement in a way that now an expert can step in and make a difference. So what we basically said is, let's pretend that every explanation has received 1, 9, and 1, 10 rating. And within Bayesian statistics, these are sort of, when you use something called conjugate distributions, it's actually a very natural idea that the prior can be like fictional observations of data. So we basically said, okay, let's pretend every one of these got 1, 9, and 1, 10 rating. And so they all start off basically with equal probabilities. But then as you actually get data like 6, 8, 6, 7, you actually now are considering your data to be the combination of all these. So this would actually raise the mean up, that would raise the mean up, and that would raise the mean up. So what that actually means is that you start off believing everything's equally good and pretty good, so you test it out a lot. But then as you get student data, you actually change the probabilities that these explanations are being presented as you're discovering, well, I think that actually wasn't as good as I thought. So this is actually how we deployed the system and what we used. I'm going to make an aside to say the nice thing about this is that you don't have to make our assumption that everything will start equally good. You could actually let, for example, Yash as a course team member say, I see explanation 1. I don't think it's that good. I'm going to give it, I think that I'm going to give it 4 8s. And what that means is I'm going to pretend that 4 students rated 8. That's just based on my judgment. Yash might see explanation 2 and say, well, that one looks good, but I'm not as sure. I'm going to give it 2 8s. So what you're essentially saying is, I was pretty confident this was an 8 because I gave it 4. I added like 4 8s in here. They'll then be combined with actual student data. But I'm only going to add 2 8s in here to express that I'm not that confident.
So I follow what you're saying.
Yes.
And then the accurate. But it also is, and I think it's a promising approach.
Yes.
But it's how to know what strength of it, how many 8s, right? That's something that's not intuitive, and it's affected by hard to know things like how many students enrolled in this.
Yeah.
So I think that's an important practical consideration for actual deployment.
That's a really good point. So that kind of gets to Daniel's question about how long should you run this for, how long should instructors do it. So
and also how to help instructors to make those kind of esoteric decisions.
Exactly. No, I think that's a great point. And there's a lot of research that people are bad judging probabilities. So I think that's a great question to look into. And that's kind of what I'm now starting to look into as I actually deploy this with an actual instructor. Because so far I've actually built the system.
Yeah, I think also there's interesting HCI, if you can action questions about that particular issue.
Exactly. And just to throw out one thought on that quickly, one guidance you might give to instructors is how many students do you expect to do it? Because if you only expect 50 students to take the explanations, then you actually want to, that will influence how strongly and how confident you want to be about your data. If you expect 1,000 people to take it, then maybe you're going to be a bit more relaxed in what you say. I think, again, the point, just to take a step back, I think these are great problems, and I'm looking forward to solving them. I think the contribution of this talk in this system is not how to solve those problems, but even that you can ask this. For example, in Google's Google setting now, you cannot even ask this question. Like, you aren't allowed to use Google's way of testing websites to say, I expect 500 people, so I want to say that this explanation is better. Or I want to say that this version of my website is better. You cannot do that. So I think this system, the contribution here is a bit different from normal. It's actually just saying, let's give you a tool that lets you even ask that question. Okay, so in terms of the instructor view, here's what this is a very prototype issue, but here's what I'd like to deploy with course teams and with the teacher, instructor for Canvas. Basically, they see the explanations, they're actually written here. So these are student explanations from my pilot deployment of how to solve a math problem. I basically did something, again, made an assumption that you might criticize, and I certainly would. Let's just pretend that there's a prior belief that these are all equally likely to be good, but it's not such a strong belief. I'm pretending I saw like 2 ratings of 9 and 10. Then here are actual student ratings. Here's a mean rating, and here's the probability being presented. So as an instructor, if I deploy the system in your Canvas course on calculus or in China X's history, you can see why you'd like this kind of interface. You don't have to touch the system or do any programming, but you do know, here's what's going out to people, here's how many people are receiving it, and here's why. They're receiving it that way because these student ratings have been given, and that's why that's 30%, and that one's as high as 55. So in terms of providing the features that I mentioned instructors should have, they should be able to see explanations and how likely they are to be presented, as well as why. They should also see how students are rating them, so that there's actual data coming in. But here's the other really nice part, which I'm really excited to get, and I think is what has been raised by Yasha, Daniel, and Jake. Can instructors actually enter their own ratings of explanations and add new ones? So the way I've set up the system, I think this is the system HCI contribution is, if you type another explanation in here, that's going to go straight out to students. So I've actually got a link between the interface, what students see on the front end, and this Google spreadsheet. So if an instructor says, well, I like these, but here's my better one, you type it in here, that starts going out to students, and so they're going to start giving ratings. And the algorithm's going to actually start presenting that to a certain number of students and automatically presenting it more or less frequently based on what their ratings are. So that's one way where the instructor can actually interact with the system, by adding new explanations. But how else could they actually interact with the system? If any of you were seeing this data, how would you want to change what was going on? Well, one thing you might say is, I see the 2 people rate that 2.5, but actually this is a really good explanation. And so the system's making a mistake. It should not be presenting 15% of the time. So you might, as an instructor, just write in this, open that doc spreadsheet, just type in, I'm going to give this a rating of 4/8. And what that's going to do is going to boost the mean rating so far. And what's really nice about that is you then are able to influence what's going out to your students. But you're not doing it in a dictatorial way. You're not saying, you could just say, you could type 100% and then say, give everyone that explanation, story done. You're not saying that. You're saying, I believe, my professional opinion is that this is a good explanation, but I want to express this a bit statistically. I want to express in terms of how many ratings I think there should have been for that. I want to vote for how good that explanation is. The algorithm then combines that with actually what's rated, and it influences what's being presented. And now the really nice thing about this is sort of one of the huge strengths of Bayesian statistics in understanding cognition, is that it allows you to specify strong pre-existing beliefs. So you can actually help guide this algorithm. But it still lets you collect data. So if you're right, and this was a really good explanation, you're going to collect a bunch of data and be like, I was right, great, and you get to the solution quick. If you're wrong, there's still the option that you're going to keep collecting data and see, actually, I was wrong. That is a really bad explanation.
Could you replace the 4/8 or whatever with a dial that's like really unsure, kind of sure, really sure, super sure, and would it practically work?
That is a great question. That's exactly the HCI question, and this maybe is something for you as course teams. And I think we should do some studies there.
I'm being forthright and say this wrong.
Exactly.
But I think I think that the substance here is interesting. The interface, I think, is quite confusing. That's why I wonder if you can replace the interface with a super intuitive one.
That's a really good point, and that's good to know because I spent my PhD studying Bayesian machine learning, so of course this seems natural to me, but actually, no, maybe it doesn't make sense to anyone else. That's actually a really good point. I think you're probably right. And I certainly can imagine lots of ways to replace this interface. Yeah. I could actually even do it so that there's a dial, and as you turn the dial, it makes up numbers there. And that would allow the Bayesian statistician to look at it and make sense, but also for the instructor to have a sense of what's happening. No, that's a really good idea. Yeah, that's a really nice idea. Okay, all right. The system will be different next week. Okay, so basically that was an overview of the kind of approach and how it actually will be working deployment. Is that right now, the system I deployed assumed no instructor feedback. It just added these prior beliefs onto what is actually rating and adjusted it. But in future versions, instructors will be able to actually influence it directly. So these are all things I mentioned the most interesting part because I was trying to think of a practical talk on how this tool could be useful. But here's what I actually did. I rolled out the simpler version I mentioned. And what I did is I basically presented the system to 150 students. So 150 learners recruited online. 150 people actually solved math problems, and they wrote their explanations. They got explanations from other people. So it was just 150, and I chose that number because that's about the size of a big class, or maybe like a couple 8th grade classes. So after running it through, at the end of that, I had my system with the algorithm saying, here's 8 explanations, and here's the probability you should present each of them. So I basically had the access explanations. For evaluation, I wanted to see, could we compare those access explanations to no explanations and other conditions? So we ran an experiment now with 500 people. So this was a lot more because we wanted to really be sure about what the effect was on learning.
So there's a stage 1, collect explanations.
Exactly.
Stage 2, try it out.
There was a stage 1, collect explanations and ratings and adjust how often it's being presented. Then we just froze the system. We said, you're not allowed to use any more data, you're done. And then we added 500 people to it. But these people didn't change the system. They just got the output of the system. Okay, so they did a pre and post test where they would solve math problems before and get no feedback. They just give the answers. And then post, we'd see how getting the explanations helped them learn. So the experiment conditions were basically practice as usual. So this is like EdX where the math problems where there's no explanations. Then there were math problems that had explanations, but these were the ones that were discarded by the system. The system did not think they were good. Then there were explanations from the system after 150 people. And then actually there were instructor-written explanations. So I think I should skip ahead since we're at about 1 o'clock, but I'll give you the key results. We looked at how all of these different conditions impacted people's self-rated gains in learning. And then also their accuracy increase, like how much did they actually increase when they got access explanations versus anything else. So learners actually did report better understanding. They rated self-rated increased that if they solved problems like normal with no explanations versus with access explanations, they actually did feel like they understood things better. Was that just subjective? Well, actually, no. When you look at pre to post tests, providing new explanations did, in fact, increase their success on solving new problems.
What was, sorry, I thought there were 4 groups.
There are 4 groups. I'm showing you. I'm not showing them all at once. I'm showing you them to answer specific questions. So here's just access and practice as usual. But now you can say, well, of course, any explanation would help someone learn. So what we're going to compare is access versus the discarded explanations. In fact, those discarded explanations don't help learning. They're not any better than no explanations at all. How much worse are explanations from Axis, which are random students writing these things, compared to an instructor? Actually, they're not significantly different.
In terms of accuracy.
Accuracy, yeah. So if you give someone problems to solve with Axis explanations versus ones written by the actual instructor, they both result in similar gains from pre to post.
Given the data you already have, could you look at how the accuracy evolves over time, since Axis evolves over time?
Yes, you can. I don't think we have enough power to do that from what I've looked at, but you can.
Let me, I just realized I don't know what the y-axis is.
Oh yeah, sorry, the y-axis here, I should have labeled that is increase in accuracy. So from pre, before you saw any problems with explanations, exactly, yeah.
But is the pre-post, those are separate from the actual activities they do?
Exactly. So you solve 3 math problems,
Yes.
then you solve 4 math problems that actually have explanations, or from Axis or from the instructor. Then you solve 3 more math problems, and we want to see from pre to post how do you increase.
So the pure practice problems people didn't gain at all.
They gain, but very little, yeah.
Is it normalized learning or absolute learning?
It's normalized in the sense that it's pre to post, so post minus pre.
They're not like, so they had 99% on the pre-test. They got 100% on the post-test.
Then there's 1%.
Okay.
Yeah. It's not like normalized as standard deviation.
No, sorry.
Okay. All right, okay, so let me wrap up here. But I think the kind of key idea here is that I basically explained the system and just presented the results that actually this one, at least, this simple deployment did help. So I think it's really great to see how we can push in a new direction. So I'm going to blaze through this, but I think really the future question is, well, how would you use Access? What MOOCs could it be deployed in? What kind of problems? What on-canvas courses? You can ask for more information on that link. And also, I'd be curious if people think, well, what other contexts could it be good to collect and provide explanations? And this is the big question I'm pushing on now. One big question is instructors interacting, but the other one is personalization. The big flaw in everything I've said so far is I assume that there's a single best explanation. But in fact, some explanations might help low-knowledge learners, whereas another explanation might help a high-knowledge learner. Or maybe there's just one fact you're missing. So what I'm focusing on now is how we can actually collect measures of those differences, and then basically, as we do an experiment, not just give everyone something more often, but give low-knowledge learners explanation 1 more frequently, and high-knowledge learners explanation 2 more frequently. And that's, again, fits very naturally into the algorithms I've been using. And also instructors can actually give us hints. Like, I think that this explanation will work for this group of students or not. And then they can actually give us a starting place. One thing I think that's really nice about this whole idea is that we have an experiment, but it's not fixed. We don't say we've got 3 explanations, let's go from now until infinity. You can constantly keep changing. You can add new explanations, new conditions. And one thing I think this suits it really nicely for is to say, if someone in Chinex or any course thinks, well, I would like a better explanation for this problem, they can actually think that as a competition. You can basically put that problem out to the world and say, anyone else can write a better explanation. Then we can actually put this into this algorithm and see what's actually working. So the idea here is that now we're actually allowing anyone to sort of participate and make suggestions. But we're not just evaluating based on our opinion. We can do that, but we're also going to actually deploy it into the world and see what the data is going to tell us about what's working. Okay, and the MOOClet technology is basically what enabled all of this. And again, as you start thinking, I talked about explanations, but you could also imagine it could even be videos, text in an explanation, and actually emails is the other application I've used so far. So just to kind of leave you with something to think about and curious to hear people's thoughts is, here's where I'm trying to apply it next, and maybe you have ideas, but explanations of math problems, learning tips about problems, it could be videos or even emails to students. And these are actually things that I've tested out, like in Khan Academy, this was an experiment, not a MOOClet. Tips above a math problem. This is something in a biochem course. And an actual, you put in a pre-course survey, inside of a lesson, changing actually the problem itself, or even actually the emails we send to people if you want to motivate them to return to courses. How would we actually use this kind of tool to experiment with different versions? And then, of course, all this data would come to you in real time where you could actually tweak the results, because that's what this tool is supposed to provide. Okay. So as I mentioned, the goal here was really, how do we help instructors easily provide good explanations by automatically using data? I presented one system to do this, which I think could be generalized. It was basically a plugin for any problem in EdX Canvas, where the students would have a view where they'd be prompted to explain, and then they'd rate the quality of explanations they got. On the back end, I use that machine learning approach for ethical experimentation that I mentioned, where instructors can actually interact and play a role. And in fact, the instructors can see what's being presented, how it's being presented, and what data is there. I sort of talked about the deployment with those 150 pilot people. And then I fixed the policies, and I actually said, well, when we evaluated it, that actually did seem to help learning. So in the future, again, question I'll leave you for is, how would you use this kind of system? What are the contexts? How might we address things like personalization? And could we actually think about running things like competitions? And I think a lot of the issues already people have raised today are really interesting ones to think about moving forward. All right, thanks a lot.
So, my understanding is that Common Core is going to be about the explanations as much as about solving the problems. So it seems to me that this, definitely could have a very big application, both with sort of teachers and students.
Okay.
Because this is exactly where, my understanding is this is where classroom learning is supposed to go.
Right. Okay, well, that's really good to hear.
And even parents, right? Because parents, right? So like Louis C.K., right? This whole riff on, how you can't help this kid with homework now.
Okay.
Because the Common Core, right, the stuff that they're expecting is like.
But if Hillary gets in, it'll all go away, right?
Sorry?
If Hillary gets voted in, Common Core will go away, right?
If Trump gets in, everything will go away.
Well, I think the whole concept of, math teaching is not just about that little magic, the box where you get the green check. It's about more than that.
I was kidding.
Yeah, guys, so like it could really
Hillary
be.
gets voted in, we're all going to be having a wonderful time explaining how she did it. So,
As the leader of this Charles, let's go back to just politics.
No, I think that's a good point, is that the idea of explanations can be a lot broader. And I mean, one interesting thought here is that that's the nice thing about online technologies, you can link people together. So parents can see what explanations are being provided by people to their students. Like a parent could actually be seeing it, they could be understanding it. Maybe this would actually help support them.
Totally. I mean, in fact, now in preschool, right, the big app is the one that allows, the teachers and the kids to communicate with parents instantly.
Oh, okay.
So, the idea of using something like this to communicate these kind of changes in the way of actually teaching and thinking and doing and whatever. And, and so all the students would be doing their explanations, right?
Okay.
So, and they may like the peer ratings, who knows?
Sure.
Maybe a happier way for them to.
Yeah, so I have a lot of questions about this, like deployment and technology. I follow. I do think you're onto something in the sense that, to me, this is a tool for problem explanations.
Yes.
It's really hard to sell. Because pedagogically, like, there are too many decisions I have to make, right? Like, do I give an explanation after they get it right?
Yeah.
Give an explanation once they get it wrong? Does that influence on other factors?
Sure.
To some extent, maybe a better starting point is to say, well, how do I just get explanations on some sort of difficult HTML, right? A piece of text or video.
Sure.
Because what your system is effectively doing is just having somebody rise in the ranks among the crowd.
I'm not saying that I agree that there are challenges, but I think they're worth pursuing.
I'm not saying that at all. I'm saying in terms
Yes,
of,
you did.
I did not. And let me say, I said it's a hard sell for me as a instructional designer.
Yeah.
To go implement this immediately for problems, and that's your starting point. That's what
Sure.
tough love is, right? If you tell me that we can start out with some simple experiment of just getting feedback on crowdsourced explanations of a video,
Yes.
right? Like that's a little more digestible for me. because there's not as many like I don't know what the word would be. These points of like I said already. Is it actually get it right? Is it actually wrong? Are they going to fill it in?
Got it.
So it's kind of thing.
Okay, no, I mean, I'm pretty
It's not
open to
about
what I
value.
applied this to. You know, I think this seemed like there were good reasons to do it, but I think there could be reasons to other things too. So
Yeah, it's not at all saying that what you're trying to do is bad. It's more like you're creating the talk around for instructional design.
yes,
Right?
well, that's good feedback. Any other questions? Yeah, but anyway, please come up to me or send me an email. I'll be happy to sort of talk about this more. Excellent.
So math lesson.
Andy, I'd love to get you in my phone.
Oh, sure. We haven't settled the whole deal.